In Paris, 1739, a cartographer named Philippe Buache drew a map of Antarctica. He shows the continent split in half. He shows an icy sea running through its interior. He marks it as conjectured, a theory, not a fact. No one had ever been to Antarctica's interior. No one had ever seen what lay beneath the ice. Buache had no satellite imagery, no seismic data, no modern tools. Yet 219 years later, in 1958, a British expedition would cross that frozen continent and discover that Buache was right. Not in every detail, but in the essential structure. How? The question isn't whether Buache got lucky. The real question is far more troubling. What did he know and how did he know it? Let me tell you about the man who drew this map. Philippe Buache was born in Paris in 1700, at the center of European learning and scientific advancement. He entered a world of high cartography and cutting-edge geographical science when he married the daughter of Guillaume Delisle, one of the greatest mapmakers of the age. Delisle was not merely a draftsman, he was a theorist of geography. His maps set the standard for accuracy and authority across Europe. By 1730, Buache was elected to the Academy of Sciences, one of the highest intellectual honors in France. He was positioned at the heart of geographical knowledge. He had access to the latest information, the newest theories, and the cutting edge of what was known about the world. In 1737, an expedition set sail from France under the command of naval captain Jean-Baptiste Charles Bouvet de Lozier. His mission was simple: push into the southern seas and discover what lay in the waters no European had mapped. The ships endured a year at sea: cold, storms, isolation. Then, in January of 1739, Bouvet de Lozier's men encountered something extraordinary. They found an island surrounded by icebergs, not small chunks of ice, icebergs the size of mountains, massive formations that towered into the sky. The expedition's logs describe ice formations 200 to 300 feet high and half a league in circumference. These were not random fragments. This was ice produced by something organized, something immense, something hidden beneath the surface. The island was named Bouvet Island. But the real discovery was not the island itself. It was the realization that such massive icebergs must have a source, and that source must be inland. Bouvet de Lozier and his men reasoned that a glacial sea, a sea of ice, must exist in Antarctica's interior. It must be calving these enormous formations. It must be organized. It must be systematic. Ice of such scale and quantity required explanation. When Bouvet de Lozier returned to France, his reports reached the geographical establishment. They reached the Academy of Sciences. They reached Buache. Buache began to think deeply about the problem. If massive icebergs are being produced at scale, where are they coming from? He reasoned through the problem like a scientist reasoning through evidence. He developed a theory. If a glacial sea existed inside Antarctica, the land must be divided. Water passages must run through it. These passages would explain the ice, the organization, the sheer quantity and systematic nature of the ice formations. In 1739, Buache published his map. He drew Antarctica as 2 or 3 separate landmasses separated by a mare glaciale, a glacial sea. He was explicit about what he was doing. On the map itself, he labeled the idea conjectured and suspected. He did not claim certainty. He presented a hypothesis based on evidence available to him. He was reasoning from data. He was thinking like a geographer should think. For the next 200 years, the map was debated. Some embraced his theory, others rejected it. But Antarctica remained inaccessible beneath thousands of feet of ice, and the interior remained unknown. The question of whether Buache was right could not be answered because the evidence was locked away beneath the frozen surface of the Earth. Then came 1958. The International Geophysical Year had been declared by the United Nations. Scientists from around the world focused on understanding the Earth's physical systems. Antarctica was a frontier, the polar regions a priority. British explorer Sir Vivian Fuchs led one of the great terrestrial journeys of the 20th century, an expedition that would bring what lay hidden into the light. Fuchs and his team set out to cross Antarctica. They pushed across the ice shelf. They carried seismic instruments, sophisticated machines that could send shock waves through ice and detect what lay beneath. They could measure depth. They could map the hidden. They could reveal what no human eye had ever seen. Over 99 days, they crossed the continent and gathered data that would reshape our understanding of the southern polar region. When the results were analyzed, the revelation was staggering. The ice of Antarctica was not a uniform layer over simple bedrock. Beneath the surface was complexity, mountains, valleys, subglacial basins, depressions in the landscape hidden beneath thousands of feet of ice, nearly 2 kilometers in some places, regions of different elevation, geological divisions, areas that seemed distinct. The ice was not passive. It was covering a world of complexity beneath. The seismic surveys revealed a topography of extraordinary complexity. There were features that suggested internal divisions. There were areas that appeared geologically separate. In essence, Buache had been right. Antarctica's interior was not monolithic. It was complex. It was divided. Charles Hapgood, a scholar who had studied other ancient maps, seized upon this discovery. He compared Buache's map of 1739 with the seismic survey data from 1958. He argued that Buache's theory of separate landmasses matched the subglacial topography revealed by 20th century science. He made the case that Buache must have possessed knowledge of Antarctica's true interior structure, perhaps inherited from ancient maps created by lost civilizations of master cartographers. It was striking. It was made with conviction, and it influenced people who read his work. The idea that ancient peoples had mapped Antarctica, that this knowledge had survived across millennia, that it appeared in fragments in maps like Buache's, this became part of popular culture. It became part of the mythology of lost knowledge. But here is where rigorous scholarship must be precise. The subglacial topography that Buache drew does not match the topography revealed by seismic survey. The divisions he imagined do not correspond to the divisions geology reveals. The specifics of his theory, the exact shapes of his proposed separate landmasses, the precise layout of his imagined mer glaciale do not align with reality. Yet, there is a simpler explanation. Buache was not receiving transmitted knowledge from an ancient civilization. Buache was reasoning from the evidence available to him. He had reports of massive icebergs. He had the logical framework of 18th century geography. He understood that ice must have a source, and he reasoned toward a structure that seemed plausible. He was wrong in the details, but he was right in essence. Antarctica was not a simple monolithic landmass. It was internally complex. The rivers that Buache imagined, rivers as great as those of Siberia, do not exist. Antarctica has no major rivers. The interior is a high desert covered in ice. It is perhaps the coldest place on Earth. Temperatures plunge to negative 80 degrees Celsius. Life cannot flourish there in conventional ways. Yet, beneath the ice, revealed by seismic survey, there exists a topography of extraordinary complexity. In that fundamental sense, Buache was correct. There was something worth mapping. There was a geography of significance hidden beneath the frozen surface. What actually happened after the publication of his map was that Buache continued his career. He created other maps, and he served as cartographer to the royal court. He maintained his position in the Academy of Sciences. He died in 1773 at the age of 73. He never learned whether his theories about Antarctica were correct. He never had confirmation. The world would not know Antarctica's interior for another 200 years after his death. The map still exists. It is preserved in the Library of Congress, in the Bibliothèque Nationale de France, and in the British Library. It is studied. It is cited. It appears in histories of cartography, and it stands as a window into how a brilliant mind approached the problem of mapping the unknown. What Buache's map ultimately proves is this. When faced with limited information about an unknown region, the human mind constructs explanations. Some will be right in general principle, even if wrong in specific detail. Some will be entirely imaginary. And some, through the intersection of good reasoning and good fortune, will align with truths confirmed centuries later. The map is not evidence of ancient knowledge transmitted through time. It is evidence of educated inference. It is evidence of Antarctica's actual complexity. It is evidence of the human drive to understand what lies hidden. When Fuchs crossed Antarctica in 1958, he was not confirming Buache's specific theory. He was confirming something more profound, that the man who theorized about Antarctica 219 years before had asked the right questions. He had wondered about the interior. He had reasoned that it must be complex. And in that essential intuition, despite errors in detail, he had been correct. But this raises a final question that lingers. In an age before seismic instruments, before explorers had even seen Antarctica's coast, how did a mapmaker in Paris reason so correctly about what lay beneath the ice? Was it pure deduction? Was it luck? Or was there something else he knew, something lost to history? The map remains, the question remains, and the mystery of Philippe Buache endures.